Dr. Janet Knodel. She is the extension entomologist. She's a professor at North Dakota State University, and she works in extension. Her presentation is going to be very colorful, it looks. And it's 2020, wet year, yet spider mite and grasshopper injury. Thank you for being here with us today, Dr. Knodel.
Thank you very much for the invite. And I also like to thank all the sponsors and all the people who organize this important event today. So yes, I'm going to talk to you about spider mites and grasshoppers. Do you want me to wait a little bit or get going?
It's all you. You're welcome to start.
Okay. Okay, I'm going to talk about grasshoppers first. There's a lot of different grasshoppers in the world, about 10,000 species. Fortunately, we do not have all those grasshoppers that we have to contend with on our field crops. There's actually only a handful in North Dakota and Minnesota. And these three I'm showing to you here on the screen, the red-legged, two-striped, and the differential grasshopper, are probably some of the most common species that we'll see out in our soybeans and other crops. Now, the young grasshoppers, we call those nymphs. They look just like the adults, but they're smaller, and they have wing pads instead of wings. And yes, they can't fly yet. They're just learning to fly, I guess, and they do not fly into fields, they'll crawl. And they go through 5 to 6 different growth stages or instars, and they continue to grow. So if we take a look at the life cycle of a grasshopper, there's only one generation per year. And to complete from the egg to adult stage, it takes 40 to 60 days. Again, that depends on species and how warm it is. The warmer it is, the faster the reproduction and the development. So let's get started in the winter. The eggs overwinter in the soil, and they're usually about 2 inches deep, and they're kind of cemented together into what we call a pod. In the early spring, the eggs will hatch into the nymphs, and they go through the different growth stages and continue to get larger with each instar. And the first instar is very small. It's only about the size of a wheat kernel. So they grow a little bit larger each time, and usually by mid-June, that's when we see the peak of the egg hatch. Some of the species, like the two-striped grasshopper, they come out a little bit earlier, and the red-legged grasshopper, that one's a little bit later. So again, it depends on the species, whether it's an earlier or later emerger. But anyway, eventually they'll get to the last molt where they become an adult winged grasshopper, and it's usually late summer by that time. And then they'll feed on the crops and mate, and then the females will lay eggs into the soil. This is very late in the summer, and it goes all the way until we have a very hard frost that'll kill the grasshopper. So there's two important times to scout. One is when they're young. Usually the third instar is about the right time to start scouting for the grasshoppers. The first and second instar, they don't move very far at all from the hatching sites. And then you also want to scout again for the adult grasshopper that is very mobile. They can fly long distances to find green fields. So usually when we see the wheat harvest is well underway and getting completed, that's when they're going to start moving into our soybean fields. Okay, each female can lay 8 to 25 egg pods, and each egg pod has 20 to 120 eggs. So that's a lot of eggs being laid. And when we have a long, warm fall, they can continue to lay those egg pods. So we can end up with quite a few eggs. We can use the common lilac blooming for the start of egg hatch. And 10 days after the first bloom, about 75% of the grasshoppers are in the early nymph stage. So that's a good indicator that a lot of farmers and crop consultants use. There is some degree day models available as well, mainly for the rangeland grasshoppers. For the egg laying sites, they like areas that are not disturbed. So that's our ditches, fence rows, any weedy areas, pastures, but they also like some of the late season crops like our soybeans, corn, sunflowers, and other crops. And they also will go into our haylands and our alfalfa fields. Okay, grasshoppers have chewing mouth parts, so they do a good job causing defoliation and stripping those leaves when the populations are real high. They will also clip those pods off and they'll chew right into the pods as well. So in the picture there of the seedling, you can see some chewing on the top part of the leaf. That's a very young grasshopper. They don't have quite the mouth parts yet to cut through the whole leaf, but you can also see on the one leaflet on the right side where they're chewed right through the leaf. So when we get high population and there's not enough food around, they can move distances to find food and migrate. Fortunately, we don't have migratory locusts anymore in North America. The Rocky Mountain locust is extinct now, and it was last observed up in Manitoba in 1902. So we're fortunate. They still have them over in Africa. But they'll eat anything that they come upon. And you can see in this old time picture here, this is an apple tree that was completely defoliated and the bark was de-stripped. So they'll eat just about anything. And grasshoppers do like warm weather. So they will not be actively feeding unless the temperatures are 68 to 100 degrees Fahrenheit. And that's why you see them in the morning basking in the sun. They'll climb up to a plant so they can get sun or go out to a bare spot where it's open and sun themselves in the morning because they need to warm up so they can start their feeding. So I took a look at the weather in northwestern Minnesota last year. I used the Polk County line as the division between north and south. And these are all the NDON weather stations that we have in northwest Minnesota. And I just took a look at the precipitation because that's very important to both grasshoppers and spider mites. And if you take a look in May, you can see that the rainfall was below the normal for both the north and the south station. And then in June, the south stations was below normal and we had more rainfall in the north. And then for July, both stations were above normal rainfall. Then August, the south had above normal and then below normal for August, and September in the fall, they were both below normal again. So I'll try to just want to give you this as the background on what happened, and then I'll explain what happened with the insects. So this is part of our IPM's crop survey that we have in North Dakota. And in 2019, Minnesota also participated. And you can see the yellow and the red squares indicate fairly high populations of grasshoppers. You can see there were quite a few in 2019, but it actually increased. You see a lot more yellow. Some of the red is hidden by the yellow squares. So it did increase the grasshopper population, and that's usually what happens before we start seeing an outbreak. We have several years of increasing, slowly increasing populations of grasshoppers. So weather has a dramatic impact on grasshopper populations. It decreases when we have a warm early spring. You end up getting a premature egg hatch, and then we get a cold snap, and that'll either kill or cause poor development of the young nymphs. They're very susceptible in this as that first instar. And then if we have a hot period in the spring, that will promote hatching, and then it's followed by cloudy, wet weather. That will favor the development of diseases that can negatively impact grasshopper development. Cool summers and early fall delays the maturity of grasshopper and shortens the time for egg laying. Well, we didn't have any of those this last year, so we didn't have any factors that help decrease grasshopper populations. Well, when do they increase then? Well, when we get cool, wet weather early in the spring, that prevents premature hatch, and it also ensures that we have adequate food supply. But we didn't have that either. Well, if we have a warm and dry late spring, that usually promotes a uniform hatch, and then we get good conditions for feeding. Then if we have a hot or warm summer with adequate rainfall, which we had, so we're going to have good food supply, our crops, and there'll be low incidence of disease. Late fall with a long egg period. Well, we definitely had that. So I had these three conditions to some extent this last year, which is why we are starting to see an increase in grasshopper populations. So there's two ways that we can assess grasshoppers. One is egg assessment, and you go out and dig up the soil 2 inches deep, and then you look for the eggs in the soil. And there you can see in the old time picture, my predecessor doing that. And then we also have nymph and adult assessments. You can do that visually and count the grasshoppers per square yard, or you can use a sweep net. And as I discussed earlier, you go out and do the nymphs early in the spring and the adults in mid-July. And we usually recommend just once a week to inspect the fields. But if we have real high populations, we should go out more often. So and here's the egg numbers per square yard and what a potential infestation would look like. And threatening is the action threshold level. So if you're doing the sampling for the eggs, which is very intensive, in the field, it would be only 9 to 17 eggs. So that's not too many. And for the nymphs or adult grasshoppers per square yard, we had the threatening stage there is highlighted in red, but we usually do either margin or field counts. And the margin is more for nymphs because they're in the ditches. That's where the hatching sites are. So you're more likely to see the nymphs in the edge, but the adults can actually start moving further and flying around. So they're more likely to be in the field. So you can see the action threshold for an adult grasshopper is only 8 to 14 adults per square yard. And it's difficult to count grasshoppers if you've tried to do it when there's an outbreak. There's so many grasshoppers moving every which way. So you can use that 15-inch sweep net, and 4 pendulum sweeps is equal to 1 square yard. So it makes sampling a lot easier. And I often will just dump the grasshoppers into a plastic baggie and take it back to the lab, throw it in the freezer and kill the grasshoppers, and then they're much easier to count when they're dead. So tillage, this is really little value to directly destroy or kill the eggs, but you can starve the nymphs in the spring and get rid of vegetation because they don't move very far as nymphs. So if there's nothing when they emerge, they will die and starve to death. Late summer tillage, you can make your field less attractive for egg laying by the adult female. And again, you can destroy the vegetation and starve some of the grasshoppers. And back in the olden days, in the 30s and 40s, yes, the plow was the most efficient tool for burying those grasshopper eggs. Oops. And we have many natural enemies of grasshoppers, birds, rodents, and reptiles, snakes. There's many insect predators that specialize on grasshoppers. There's a blister beetle where the larvae of that blister beetle feeds exclusively on grasshopper eggs. The parasitic wasp, Saloninae, that one is specific to grasshopper eggs as well. And this one has been widely used for biological control for other insect pests as well. Taconid flies as well will kill grasshoppers and spiders. And these are very important, these natural controls. And they did used to use turkeys and chickens to help control grasshopper outbreaks in the 1900s. Some other natural enemies are these little small red mites that you've probably seen on the body of grasshoppers. However, they're not effective in killing them, but they will reduce the vigor of the grasshopper so they won't maybe lay eggs or as many eggs. Nematodes, there's thread worms or hair worms they're called, get inside the body and will kill the grasshopper. There's protozoans, Nosemia locasi, and this is available as semaspore, which is a bait that you can use. And there's a fungus, Entomophagia grilli. It's called summit disease because it'll climb up to the top of the plant and cling to that plant with its heads pointing up. And eventually the body will disintegrate, the abdomen will fall down to the soil, and there the spores will continue the life cycle. And they found some strains of summit disease that are not dependent on moist weather. So this particular fungus can infect grasshoppers even when it's dry. Here's some of the insecticides that are registered in soybeans for grasshopper control. That top one there is an IRAC class 15 Dimlin. And this is an insect growth regulator, so you have to target it towards the immature stages of grasshoppers. 1B is the organophosphates that we have. And again, this isn't it's a partial list. I didn't list everything. And then we got some premixes. And then the 3A is all the pyrethroid insecticides. And then some premixes, and then Stewart 22A. So there's quite a few different active ingredients that are available. And be sure you watch the pre-harvest intervals because a lot of times the grasshoppers are most economic in the adult stage. So they're moving into the field late in the season when you're getting closer to harvest. So we did have some grasshopper problems in my soybean aphid trial this year in the soybeans near Castleton at the research center there. And we decided that we should do a insecticide trial on the grasshoppers since there were so many. So as you can see, we had a low and high rate of many pyrethroids, and a couple of premixes, Cobalt and Hero. And the yellow bar indicates grasshopper per square yard. And then the blue indicates percent defoliation. And the orange is the yield in bushels per acre. And hopefully you can see the red box. That is the untreated checks. And you can see we had significantly higher grasshoppers and percent defoliation and lower yield in the untreated checks. And then we had the insecticides. There was no significant differences between the different insecticides, but we did have a significant difference between all the insecticides and the untreated check. So in the insecticides, we had significantly lower grasshopper populations and lower defoliation and higher yield than the untreated check. We tested the low and high rate of each chemical. And in general, with the low rate, we had a higher percent defoliation. That was not always the case. For a couple of them, we had Hero and Warrior. We didn't see that trend, but most of the time we did. And you will get a higher residual using the higher rate, which is good if you have grasshoppers that are moving around, because they will reinfest fields. And of course, we can go back to the olden days and try the bug zapper to kill grasshoppers for $16,000. Okay, I'm going to move on to the two-spotted spider mite. They're very tiny. You're probably going to need a hand lens or a head-mounted magnifier. They're about 1/16 of an inch. And the two-spotted has two dark spots on the abdomen, and that's why it's called the two-spotted. Okay, they attract many, many, many species of plants, not just our crops, our ornamentals and trees. I believe it's over 500 different species of plants. Their life cycle is very short. They overwinter as eggs, often in alfalfa. And the faster the temperature, the faster the reproduction at the hotter temperatures. So it can take anywhere from 5 to 19 days to complete its development. So you'll end up with multiple generations throughout the season. Spider mites damage the crop with their piercing, sucking mouth parts. They feed on the individual plant cells and they'll exude the plant sap in there. So you'll first see the damage as little stippling or white spots on the leaves. And then also there's some yellowing or bronzing that'll eventually happen as it gets worse, and then leaf drop when you have severe infestations. They also web, as you can see in the lower picture, and that's how the mites move and disperse. Besides crawling, they'll climb up to the top of the plant and then balloon on strands of silk with the winds. So they move kind of similar to spiders. So, and the problem is with the feeding on for spider mites is the plant loses its photosynthetic ability, so it can't make any food, and it also increases water loss. So this in turn will reduce your soybean yield. So there's just some close-up pictures so you can see it well. Those little white spots are the stippling from the mite, and they're mainly on the underside of that leaf. And here's the yellowing in the middle. You can see a little bit of bronzing starting to occur on the lower leaves. And then the webbing. I took this picture in a field that was completely destroyed. The spider mites completely destroyed the soybean field. And this is right next to the road, and the webbing actually was capturing all the dust, and it was actually making the infestation worse. So you need to get out there and scout for spider mites. The best place to start is on the edge because spider mites are moving out of the ditches, alfalfa fields, usually after the ditches are mowed or cut for the alfalfa field. They'll start to move to find some greener food sources. So be sure you look first in the edge to see if you have spider mites, and then they often have a leading edge as they move into the field. So get out and check multiple sites in the field. We do have an NDSU YouTube video for scouting for spider mites and soybeans. If you want to watch it, just Google it and it'll pop up. So we did scout for spider mites in the IPM crop survey program, and you can see we've had a few spots in 2019 and 2020, but nothing significant. We were drier out in the northwest part of North Dakota the last 2 years. There's many natural enemies of spider mites, just like the grasshoppers, and these are really important for keeping grasshoppers in check. There's the minute pirate bug, lady beetles, lacewings. There's many more than what I have listed here, and the predatory mites are very important. They're a little bit larger and they have longer legs and they can move faster and they catch the two-spotted spider mite that way. One of the problems with these predatory mites is they do not like the hot temperatures that the two-spotted spider mite likes in the 90s. They prefer the cooler temperatures in the 70s, so they don't do as well when it gets super hot. Hey, spraying for spider mites, the crop is most susceptible from R1 early flowering up through R6.5 past full seed. And the University of Minnesota, Ken Osley and Bruce Potter developed a action spray threshold just based on stippling and where the stippling occurs. So it's mainly when the stippling is most heavy on the lower leaves with some progressing into the middle canopy. That's when you need to take some action and do an insecticide miticide control to prevent yield losses. So in some of the problems we have from spraying for mites is we don't use enough water volume to get good coverage. We recommend 18 to 20 gallons per acre is best for mites. Think about where the mites are on the underside of the leaf and at the bottom of the canopy when they start out. So we have to get that chemical down into the plant. And by air, 5 gallons per acre. So use the higher label rate and adjuvant if it's real dry or you have a severe mite infestation. That'll help get the droplet down to the plant before it evaporates. And don't use pyrethroid insecticides, please. 3A. They will actually flare spider mite populations. It increases their reproduction and they lay more eggs. There's only one exception that you can use, and that's bifenthrin active ingredient. Then the insecticides, these are mites. They're not insects. So these insecticides do not control the eggs. Need to go back 5 to 7 days later and see if you need to do a respray. The second treatment, again, if we need to do it, you need to alternate the modes of action so we don't get insecticide resistance. So let's say we sprayed with a Lorsban organophosphate insecticide, then we need to rotate for the second spray to a pyrethroid bifenthrin active ingredient or a miticide. So this is from Archer and al. On spray coverage. They did an aerial application at 2.5 gallons per acre. And you can see most of the droplets were deposited in the top part of the plant, not the bottom part, and that's where the mites are. Upper surface, 62% of the droplets landed there. Where are the mites? The lower surface. And the outer leaf, 86% was on the outer, and the inner only 14. So coverage, very important for mite control. Here's some of the insecticides and miticides that are registered. Again, it's not a complete list, it's just a partial list. You can see the 3A is the pyrethroid, one's the premix hero, and the gray is the organophosphate, lorsban, and dimethoate is the two active ingredients we have, and some premixes. And then at the bottom in light orange is miticides. And you'll probably notice that the miticides are more expensive. So take a look too at the pre-harvest intervals if you're close to harvest and select one that can work for you. So last in 2019, we had defoliating caterpillars in both soybeans and dry beans. And it was up in northwest Minnesota. And it was mainly green cloverworm and thistle caterpillar that we were seeing, but they were doing quite a bit of late season damage and even getting into some of those pods and chewing on the pods. So what did we use for control? Probably a pyrethroid insecticide. I know Warrior and Generics, lambdicylhethorine, probably the most popular insecticide in soybean, was probably used. What does this do to the mites? Flares them. It will increase them. So we might have been increasing some mites way back in 2019. And usually we have soybean aphid. Don't forget our old friend, soybean aphid. So we haven't seen them here in North Dakota for 3 years, but they're still around. So remember, if we in other crops too, not just soybean, if you're spraying a lot of pyrethroids in your alfalfa for pea aphid, you may be flaring spider mites there, and then they're moving over into your soybeans. So it's gotta think broad here. And we also disrupt all of the natural control when we use our insecticides. Some other factors is drought stress, which we haven't seen a lot yet of major drought yet, but it's coming, and low rainfall, hot temperatures, and we also have insecticide resistance in spider mites, just like we do with the soybean aphids. Dr. Ian McCrae documented lorsban chloriophos resistant in spider mites up in the Northwest. So, and pyrethroid resistant occurs in other areas of not our states, but down in Texas. So these mites are rapid reproduction, so they're able to adapt and become resistant. So we need to rotate mode of action, very important. And then also sometimes the natural enemies cannot keep up with the reproduction of spider mites. So that's another factor that we need to consider. And this is what's coming our way so far. This is the drought monitor. You can see North Dakota looks terrible. Most of it's in severe drought. But even in northwest Minnesota, it looks like moderate drought for this next year and abnormally dry in the rest of the state. So it looks like we have conditions going into this year that are going to favor both grasshopper and spider mites. So definitely something we need to get out and scout for this upcoming year. And here's some soybean insect resources that I have available. The soybean gall midge and white mold gall midge in soybean is new, and also the common arthropod pest of soybeans in North Dakota. And you can download these by just Googling them, NDSU in the title, and get a PDF online. And here's some of the other. We do have a soybean production field guide for North Dakota. So I'd like to thank you for your attention, and I'll be happy to take any questions. if there's time.
Thank you, Dr. Knodel. And there are a couple questions. We'll at least get through some of them. The first one is, will we have chlorpyrifos available by midsummer applications? Is it back under EPA review, or what is the status there?
Yes, chlorpyrifos, which is Lorsban and generics, are it's an organophosphate insecticide, and it is being reviewed. And I think we will still have it. They'll have to do this year at least. They'll have to do a phase out. So it'll take, a few years to phase it out, or at least a year. I don't know. But yeah, I think in soybeans we'll at least have it for this year. It depends what their decision is.
Okay, thank you. The next question is, what was the plot size and experimental design of the insecticide screen on soybeans?
We do a randomized complete block design, and it was 10 feet wide by about 25 feet long, the plots. And we didn't get the normally at Castleton, we'll get 50 to 60 bushels per acre, but they had very wet year there at Castleton. So that caused some problems with getting a good stand established. And that's why we had lower than normal yields there.
Okay. And we'll try to get through a couple more of these, and then if there are still more questions for Jan, we'll have her answer them directly in the Q&A. But one that came through on the chat, is there a specific soil type or location that adult grasshoppers prefer to lay their eggs into?
Yes, that's a very good question. And yes, they do like sandy or lighter soils to lay eggs. So if you have and often on a hilltop too, they'll like the south side, which will warm up faster in the spring. So if you have sandier soils, it's easier for them to lay eggs.
Okay, and just the last one was talking about the spray air sprayer. I believe that question came in when you were talking about the insecticide guidelines. And they were wondering if it was better for that application in terms of getting enough water volume, proper coverage.
Yes, I think they meant by airplane, but yeah, we do recommend 5 gallons of water per acre if you can. If it's real hot out, you can also spray later in the day so you don't get quite as high evaporation, or add an adjuvant. So I'm not sure if I answered the question, but by land ground rig, you want to go 18 to 20 gallons per acre, because you just need the coverage, especially for mites. In our grasshopper insecticide trial, we went 18 gallons per acre.